Welcome back, everybody. Welcome back to the channel. So today we're going to continue where we left off. This is going to be part 3 of how to process methods or how to post-process methods in a compiler. Now, before we get into that, I'm actually working on a pretty interesting feature in the programming language. Now, I know some of you have asked me about whether or not I was going to be adding object serialization into the programming language. Well, that is actually a feature I'm working on right now. So that's going to be pretty much a episode right around the corner, most likely after this one, so we can just get it out of the way because it's actually not that complicated. So basically, really quick, I know this is like off topic, but I'm going to put a timestamp in the description below if you want to skip over this. It's only going to be like a minute or so of me explaining it. Basically, you create a class of whatever, you put some values in there, and then I print out the values before, export it. So there's going to be a concept of exporting, and then you can import the data. And I'm basically exporting this in object to a file called class.txt, which is basically just a binary file with some data. But there's basically now a way for you to represent classes in the programming language, and you can like dump the data to a file and then import it back out from a file and access that data and information as if it was stored in memory. So it's pretty cool. I'm pretty excited about that. But let's get back to the video today. So since this is pretty much going to be, I'm pretty sure, the last episode, this one isn't going to be that long. Basically, now we're still in the resolve class methods function. So we talked about how to add a default constructor in the previous episode, so now let's kind of just continue on. I don't think I mentioned this in the previous episode, but after you add the constructor, you always want to make sure you remove the scope. That is very important. And you also want to restore the primary class. So I do restore it after retaining it, because you want to put it back to the old class, because as you see, we dynamically call into this function if there is another class nested inside. So you want to make sure that everything is all recursively working together. So continuing on, once we kind of have our switch statement set up for resolving all of our class methods, when it comes to resolving class methods, you want to do a couple things. So first, if there's a subclass inside, so if you have class of A and then you have another class of like B inside of A, you want to recursively call back into this function, and you just want to pass in a branch. And based on how our parser works, it's going to work all the same. So we're going to recursively call back in here. It's going to figure out whatever the class is because we didn't pass the value here, and it's just going to work flawlessly. So we don't really have to do anything. Now, if it's an interface, we also do want to recursively call back into the same function as well. And that basically leaves like 4 or maybe 5 different ASTs or declarations that we need to process. So the first one that's going to be the easiest is resolve class method. Now this one's going to be pretty similar to resolving a global method. So I'm just going to go through it. So first thing you want to do is call the get extension function class. We've already gone over this, so I don't need to go over this again. After that, you want to check to see if the resolved class is null. If so, that means that obviously this is a normal function. Now it's not a normal global function. This is a normal class function. Now it's just copy and paste it. And then you just call resolve method. And we've already gone over this function as well, so I don't really have to go over that. But once you resolve the method, you're good to go. Now, in the case where you have a resolved class, you can see here we, of course, do our checks. We want to make sure we're not trying to add an extension function to a class that is basically a stable class. Now, this goes against convention. To be honest, I really don't like the fact that you can put extension functions inside of classes, because in my opinion, that's a bit confusing. But just to be comprehensive with the language, you can basically say, I don't know, string dot and then some function, and you can basically add that function to the string class, but inside of another class. Again, this is not advised because that's just very confusing. If you're going to do an extension function, it should be a global function. Now, you guys can obviously block this. So if you want, what you could do is, if you don't want them putting extension functions in classes, if the resolve class is not equal to null, you can just throw an error. So, it's up to you guys. I do support it though, and it's pretty much the same thing here. So if the class is a generic and the class's generic owner is equal to null, that means this is the original generic class. We add this extension function to the extension function tree. Otherwise, we say resolve method with the current class. So that's pretty much going to be it for compiling or resolving class methods. So if I go back to compile, I'm going to go back to post process, resolve all methods, resolve class methods, and that's pretty much it for this one. So now we want to process operator overloads. So if we have an operator overload inside of a class, then here's what we want to do. So it's going to be pretty similar to the method resolve function, so just keep that in mind. You want to create a list of flags for your access flags. You want to parse the method access flags. We've already gone over that function as well, so I don't have to do that. And pretty similar to other methods, if we don't have the public, private, or protected access flag, then I just default all methods to public. Otherwise, if we don't have any flags at all, then I just default the value of the access flag to public. Now, if the flag is static, I say static operator overloads are not allowed. This is just a formality in my programming language because typically the way that operator overloads work is if I have, I don't know, define operator and then plus, and then I don't know, let's say I have a var here or something. Then let's say this is num m, and I want to have an operator overload where this a class can be added with a numeric value. Well, that only makes sense if we have an instance to add the data on. If you just say, a, and then plus, and then some random value, that's just kind of weird. So I only allow operator overloads to be non-static in the programming language. You guys can do whatever you want though. And after that, we set up our parameters. We get the name as the first element plus the second element. So I'm actually going to put a breakpoint here and we can actually see what the name of operator overloads are going to come in as so you guys can know what to expect. All right, so as you can see, the name is going to be operator and then whatever the operator overload is. So that's what you need to expect coming from the parser. If you don't have that, then that's obviously a problem. Because when it comes to actually calling operator overloads, so if I go back here, and let's assume this is in fact a instance function, as it's supposed to be, we can say n dot underscore a, which is representing the a class, and then dots operator, and then plus, then we can actually call the operator overload function. So in order to call this properly, you're going to need to have the name of the actual function be that value. Now, as far as the operator, of course, we're going to pull out the second item in the AST as a token, and that's going to be equal to the operator that this operator overload is going to represent. Now, you want to validate the method params again. Again, we've already gone over this, so I don't have to go over that. And then after that, you want to parse the utype arg list, and then you want to validate the parameters, so I don't have to go over that because we've already talked about that. You set up the metadata the same way as always, and then you set up your method function by passing in the important data such as the name, current module, the current class, dynamic ID, the parameters, the flags, and the metadata. And of course, we set up our full name. Just as always, we get the full name of the current class, we put dot, and then the actual name of the actual function. Guys, you need to take note that the full names are going to be the same convention in the entire programming language because we're actually going to be using these full names in our virtual machine. So if we try to access a class, we're going to need to make sure that everything has this convention, or if we try to access a field or a function, it all needs to be in this convention. It's also used as well for our code generation system. So if you guys remember, when we get to the point where we start generating C++ code, this is going to be the fully qualified name of every single function that we're going to be creating. So it's very important that the format is correct there as well. So there's a lot of things that are actually going to be using this format. You also want to set up your other preliminary data as well, such as the AST. The function type is going to be a function operator overload. The address is going to be just method size plus plus. And the overload we're going to set here. And then after that, you want to call compile method return type again. Again, we're going to go over this function at a later date because this function is just way too complicated and it will lead on a rabbit hole of videos that I just don't want to get into right now. So make sure you call this function though. Any functions that I say to create but we're going to use later, I would just recommend just putting them in and calling them, and then maybe putting like a to-do and say like we need to edit these later. That way when it comes time to talk about it, we can. Now, by the way, guys, if I miss any functions, now I'm doing my best to go over everything in this compiler, but it's 20,000+ lines of code. So it's a very good chance that I might miss something. So if I do miss a function and we're deep into other concepts in the actual compiler, then definitely put it in the comment section below and I will let you know if either I missed it or if we're actually going to circle back around to it. So definitely pay attention to that as we kind of go through the compiler. And after that, so you want to add the function. Now we're going to add it just like we added the global function in the same way. We're not going to do any complex stuff like when we tried to add the default constructor. We just want to add the function to the class, right? It's very simple because we know that, this class is only going to have one of the same type of function. So we can just pass a simple parameter match, and we pass it the method that we want to try to add, and then the class that we want to add it on. And yeah, we've already gone over this function as well, so I don't have to talk about that. Now, if we couldn't add it, then we'll say previously defined function whatever is already defined in the scope. And we find the function from the previous declaration. We get the metadata from that function, and then we say, function previously defined here. So that's going to be our note, and then we free up the method, obviously, and delete it because we couldn't add it. And that's pretty much going to be it for that. So if I go back to compile and kind of go through the nested functions again. So I go back to compile class. So that was how we process operator overloads. Now let's look at how we process constructors. When it comes to constructors, it's more or less the same as well. So we create our flags, we do our preliminary setup where we, process any access flags if we have any. And if we didn't find the public, private or protected, we default it to public. Otherwise, default it to public if we have no arguments. We get the name of the constructor, and you need to make sure that it matches the name of the class, by the way, because obviously if it doesn't, that's bad. And then we parse the utype arg list and validate the params as we always do. We set up the method as the same way as we always do, and then the method pointer, again, all the same stuff. We set up the full name, we set the function type to function constructor this time, and then we set up the utype equal to nil utype. Now notice I didn't set the utype on the other function, the operator overload, because we don't know yet what the return type of that operator overload is. So that's why I didn't set it there. Plus I had a compile return type function that we called immediately afterwards anyway. But after that, so if the name is not equal to the class name, then we need to verify that this is actually true. So if the current class is a generic, then I get the adjusted name by, getting the name of the actual function and then adding these two characters here. And then I check to see if the adjusted name is equal to the generic owner's name. Because if you remember, the generic owner of, for instance, the list class is going to be this, whereas the actual created list class, it's going to be list of var or something like that. So this is going to be the actual name if we create a generic class. And that's it. So, and then after that, we say, constructor, whatever, must be the same name as its parent class, because obviously it can't not be the name. Then we just add the function as normal. So I'm not going to go over this. It's literally the same crap that we just talked about in the previous function as well. The only difference is instead I say constructor here. So I say constructor is already defined, constructor previously defined here. So just make sure you change the name of the actual error message when you print out the error. So that's pretty much it for constructors, and yeah, that's it. So the last thing is going to be class mutation methods. So if, for instance, I don't know, we have like this class here, and we mutate the string class, and I don't know, we have like some functions in here, define work or something. We also want to process any of those functions as well, because those are valid functions that need to be processed. So for resolve class methods, you pass it the branch, and then you compile the reference pointer. So you want to figure out what class are we mutating, and all we care about is the class name. We don't care about any of the crap that's afterwards, like what's the base class or if it has any inheritance for interfaces. We just care about the class name. So you want to compile the reference pointer and access the name AST and get the reference pointer AST out of it. And then you want to get the current class by resolving the class reference and again passing in that same AST here, as well as the pointer of the reference pointer. And then you also want to say allow generics to true, because again, remember, this is a mutate declaration, so we can have a wide range of classes. Now, if the current class is not equal to null, that means we do have something to process. If it is a generic class and the generic owner is equal to null, we say do nothing, it's already been processed. And this is a bit of a weird case. We will see where this gets processed later. Generics are kind of a magical class, so we will definitely see when all this stuff gets processed. But on the other hand, if it's just a regular class, then we just say resolve class methods. This is the exact same function that we've just been talking about. So we just pass it the current class that we resolved here, and that's it. So that's pretty much the entire way of how I process methods in the actual programming language. So if I go back to post process, after that, once you have successfully finished the resolve class methods function, now we need to go back out to the high level And now that we have this, if you have an interface, AST interface, you want to call the same function we just talked about. And then for AST mutation declarations, you want to call the resolve class mutations function. And that's it. So we've literally gone through the entire flow of how we pretty much process methods in the programming language. And now we're kind of at a point to where we're now ready to resolve all delegates. Now this is pretty much going to be the function where we pretty much process all of our interfaces in our programming language. So this one's a bit more of a complex video. So actually next episode is going to be about how to add object serialization into your programming language. And then after that, we'll talk about this where we can basically figure out how do interfaces enforce the rules that they do when it comes to implementing methods inside of classes and so on. So this one's going to be a pretty fun one as well. So hope you guys enjoyed the video. As usual, if you have any questions, definitely put them in the comment section below. And of course, if you're new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.